Hello, welcome back. Today let's try to solve another Leetcode problem, coin chains. Basically, we are given an array of coins and we also have an amount. We just need to find the minimum number of coins with the sum of them equal to this amount. For example, we have a coins array of 1 to 5 and the amount is 11. We just need to have 5 plus 5 plus 1 that equal to 11 and the result is 3, which means the number of coins. Let me first go to the whiteboard to finish my explanation and then go to the code editor to finish the coding. So for our problem, it's basically a knapsack problem. Yeah, maybe you think it's a greedy problem. Actually, it is not. If we have a coin value of 1 to 5, of course it is greedy because the exchange system in each country, they designed their system use the greedy. But for our problem, we don't have 1 to 5. We may have other values like 7, 5, 2, and 1. So what is the minimum use greedy? We can choose the 7 first, then choose the 2, and then choose 1. It is the 3. But for us, we need to find 2, 5. If we try 2, 5, it is only 2. That is the minimum. So for this problem, actually, we cannot use greedy. If our value is fixed, for example, like 1 to 5, like the exchange system designed in each country, they used the greedy method to design their coins. Yeah, but for us, for our coin chains problem, actually, it is not a greedy design. Yeah, because we have different numbers. It is a knapsack problem, and it's also a unbounded knapsack problem. Unbounded means we can take as many coins as we can, as we need. For example, this is the coin's value 1. We can take many ones. For coins 2, we can take many 2s. Yeah. Now let me explain how I'm going to approach this problem step by step. Yeah. For this problem, normally we use a DP 2D array. Yeah. But we can also use a 1D array. I mean, compress the memory by 1D array is also an optimization. And also for understanding, if we did the knapsack problem, yeah, if we use a 1D array, we just need to understand what is the meaning of our DP array and how to design our DP array, because we need to calculate the minimum number of coins for each amount. So we need to define a DP array. So the length of the DP array should be amount plus 1, because we need to have a zero index. This zero index means if we don't take any coins, if our amount is 0, do we need any coins? No. So how many coins do we need? So this is a 0. Yeah, but for other amount of coins from 1 to 11, for our example, I will define as infinite, because this is the initial beginning. If I didn't take any coins, I will think it is infinite, because if I didn't find a number, like if this result is infinite, I will return -1. This means that is not possible. But if I can find something, it is an optimization problem. If I can optimize by using the coins one by one, and if I can get a smaller value, of course I will return the DP -1. It is my final result. Yeah. Then we need to try to find the transformation function for our DP formula. Yeah. So for the DP formula, we need to understand the problem. Basically, it is the minimum. Yeah. If we need to calculate the minimum, normally the DP array should be the minimum. Yeah. The minimum with taking the coin or not taking the coin. If we are going to take the coin, it is yes. If we take this coin, it is I minus the coin. This coin is I tried one by one. For example, I will try the first coin first. I will try the first coin. It is with value 1. So this value, this I is from the index. It means my amount. If I take this coin, I need to use the DPI minus my coin and plus 1. This one means I take this coin. If I did not take this coin, I just need to use the DPI. So this means I don't need to take the coin. Of course, it will be DPI. For example, I will update those values by the first coin. Now my coin is this. Now my coin is this value 1. If I update this coin, so from the first index, I'm going to update it Yeah, now let me update this one. So from the first index, from the beginning, it is infinite. Now I'm going to take this coin. So if I take this coin, it means the value should be the amount minus the coin. So dp1 minus 1, so it is 0. 0 plus 1, it is 1. Yeah, I will not explain every index, but I will update the first loop if I choose coin 1. So from here, it will be 2. For example, if this place, it is a dp I equals to 2, 2 minus the coin 1, it is 1. dp1 plus 1, dp1 plus 1, it is 2. 2 compared with infinite, it is 2. Now, I will just finish all my loop for other amount if I only use coin 1. You can calculate by yourself, but here for saving the time, I will just try to fill in all other positions, and then I'm going to try the second coin. So this is the first coin. Yeah, you can try to understand that. Yeah, for example, if we try to have an amount of 6 and we only have values of 1, how many coins do we need? Of course, it is 6 because we only have a value of 1. Yeah, so this is when we tried our first coin, so we get an amount. So this means if the coins array with only 1, we have our DP array has already been updated. Yeah, I did something wrong. Here should be 9, and here should be 10, and here is 11. So this means if we only have the coin 1, we don't have any other coins. So what is the minimum? It is 11. Yeah. Now we are going to try the second coin because we are not finished yet. Now let's try the second coin. If we can try the second coin, let's say if we can optimize our problem. So for the knapsack problem, basically it is an optimization problem. Now we are going to try one by one for all of the coins to try to see if we can optimize our DP array. Now we are going to try the second coin with the value 2. If we have a value of 2, we are going to start from the index 2 because this I minus the coin means my amount minus this coin. Yeah, if I take the coin with a value of 2, what is the minimum amount I should have? At least I should have 2. Yeah, because this coin's value is 2, I will take this one. So that is why I will start from the index 2. Now I will update my DP array. So from the DP I equals to 2, so the DP2 equals to minimum of DP2 with I. So here I equals to 2, I minus my coin's value is 2. Yeah, 2 minus 2, it is 0. So 0 plus 1, so this is 0. Yeah, the index is 0, it is 0. 0 plus 1, so it is 1. Yeah, we should also understand that if we can take a value of 2, how many coins do we need? Our amount is 2, so we can directly take this coin. Yeah, so this is why it is just 1. Yeah, if we understand the DP transformation function, and then it should be easier to fill all those numbers. So from here, if it is 3, so should be 1 plus 1. I minus coin plus 1 should be this place plus 1. So here should be 2, and here should be this 1 plus 1. It is 2, and here should be this 2 plus 1. It is 3. It means so if we only choose coin 1 and 2, if our amount is 5, yeah, we can try 2, 2, and 1. This is greedy. Yeah, it's like greedy. But as I said, if we only have 1 to 5, of course we can use greedy to finish the problem. But actually in real problem for us, it is not 1, 2, and 5. It may have other numbers. So that is why we cannot use greedy. But here, let's just finish our DP transformation function. Let's fill in all the numbers. So here should be 2 plus 1, it is 3. And let's go to the next one. It is 2 plus 1, it is 3. And let's update here. Here should be this place because this I equals to 7 plus the coin 2. It is a DP5. It's 3. and 3 plus 1, it is 4. Yeah, so I hope it should be right. Yeah, I think it is right. Now let's update this one. It should be 3 plus 1, it is 4, and here it is with index I, it is 7 here, it is 4 plus 1, it is 5, and here also 4 plus 1, it is 5, and let me update the last one, it is 6. I know it takes time, but for us, even when we try to understand the question, we need to take some time. But once we're familiar with it, we just use the template to finish it in a few minutes. But from the beginning, we may take hours to understand why we need to update like that. Now let's update the last one. It is with COI values of 5. Now we are going to try the last one to see if we can optimize our DP array. Now let's try this 5. Yeah, if we try to update the COI with 5, as I said before, we are going to start from the index 5 because we don't need other indexes. Because if we take this COI 5, yeah, we are going to have at least with a value of 5. So this means why we are going to update from here. So dp5 minus my COI is 5, so dp0 plus 1, 0, here is 0, with value 0 plus 1, it is 1. Now I'm going to update the next one, it is 1, this one plus 1, it is 2. Now let's go to 7, 7 goes to 2, here is 1 plus 1, it is 2. Now let's go to 8, it is from 3, it is 2 plus 1, it is 3. Now let's go to 9, it is 4 with value of 2 plus 1, it is 3. Now let's go to 10, minus 5, it is 1, it is 1 plus 1, it is 2. We can also understand that if we have a amount of 10, we can use 2 COIs with value 5. Yeah. Now let's go to the last one. Here is 11. 11 minus 5, it is 6, with value 2 plus 1, it is 3. So finally, we are going to return dp minus 1, it is 3. If we didn't find the value, if it is infinite, we are going to return a minus 1. Now let's just go to the code editor to finish the coding. Actually, the coding is not so long, but it's really difficult to write if you don't understand the knapsack problem. Yeah. Now, if you understand that, you should write it easily. We just need to define our DP array, as I said. From the beginning, it is 0 with the index 0 and plus the infinite times the amount. So this is what I said. So the DP array, the length is amount plus 1. The first place is 0. This means if my amount is 0, I don't need any COIs. And then initially I will have an infinite. Now I'm going to loop through my DP array for I in range. So this will be start from 1 because the first place I don't need it. It's already be 0. And then I'm going to start from the index 1 with amount plus 1. Yeah, the amount plus 1 is the length of my DP array. Yeah, you can also use the length of DP. It's the same, length of DP. It's the same. Now I'm going to try the COIs one by one. So for COI in my COIs array, I'm going to check if this I, the value, is more than and equal to the COI. I will update my DP array. As I said, this index, this means I will take the COI, I will try if I can optimize my DP array. So the DP array, dpi will be the minimum of dpi with dpi minus the COI. This means if I take this COI, what's left? Yeah, it is the dpi minus the COI. And if I take this COI, I need to plus 1. Now, I've already updated my DP array. I just need to return dp minus 1 if dp minus 1 not equal to infinite. yeah, it means I have a value not equal to the infinite. Else, I'm going to return the -1. Yeah, basically this is the entire function. It is only 6 lines of code, but it's really difficult to think. Even now, you think how to do it. After a few days, you may forget. But what you need to do, you just need to understand the snack problem. What is a snack problem? It is a 0, 1 snack problem. It means, yeah, it means you can only take one. After you take this one, you cannot take it anymore. And there's also unbounded knapsack problem. It means for each coins, we can take as many as we want. And also, this is basically for the DP transformation function. It's basically about if you want to take the coin or if you not take the coin, you need to find the transformation function because we need to have the minimum of coins. So we need to check the minimum. Now let me run it to check if there are any mistakes. Yeah, as you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, it's a bit slow, but let's just wait. And I think it passed all the testing cases. And now, at the same time, we can analyze the time complexity. The time complexity, as you can see here, this is only the amount. If this number is m, the amount, the value is m, and how many coins, the length of the array is n. So the time complexity is m times n, and the space complexity is only m. M is the amount, the length of the array. Thank you for watching. If you think this is helpful, please like and subscribe. I will upload more Leetcode problem. And if you think this is helpful, you can also check my Koi 2 videos because I didn't record it. I will do that. Thank you. Bye.